Hello and welcome to Visual Studio. I'm Santier, and this is going to be the first episode in a new series that I want to do called Let's Program. Now, a lot of people don't have experience with programming, so what I want to do here is provide a bit of an overview about how these things work, just so that way people can follow along. This isn't going to be an in-depth tutorial, rather it's going to be kind of a quick overview, and specifically I'm going to be looking at C#. One of the things that I really enjoy doing is making these little simple utility programs for myself, or apps as Apple has successfully gotten people to think of them as. And I find these to be, there's all sorts of little things that I want to do, and I've made my own music player, for example. That's definitely a more advanced sort of thing. But when you can make your own programs, you get the features that you want, provided you can figure out how to make them. So Visual Studio is the premier integrated development environment, or IDE. It's got all the sort of tools you need kind of together in one place, so that's why it's integrated development environment. And Visual Studio, like I said, made by Microsoft, is kind of the premier one. Also, they have a community release that's free, which is, this is 2015, there's a 2017 now, last I saw. And they've added some features to that. I haven't messed around with that one a whole lot. But I'm just using this one. So the first thing that we need to do is we need to make a new sort of project. And they call them solutions because programming is all about solving problems. Therefore, it's your solution to your particular problem. So they call them solutions. So let's go ahead and make a new project. And this will bring up a little dialog that lets me specify what sort of project I want to make. It might take it a moment. That happens. So this is Visual C#. There's a couple of different options. There's these Windows apps. This is a newer thing. I haven't done a whole lot with them. I don't have very much experience with them. So I'm going to be doing a Windows Form application. There's also like a console application, all sorts of other stuff. There are other languages that can be done in here. C++ is another language I've used a lot. But C++ is significantly more complicated to do things with. It has lots of advantages, but it's more complicated to use, and it's more powerful in a sort of way, but that's a double-edged sword because it's really easy to hurt yourself with it too. So we're going to go ahead and go to a Windows Forms application, and I'm just going to call this one Overview, because I didn't pre-plan this at all. This is something you're going to expect from the series. It's kind of a let's figure stuff out. I haven't pre-planned what I'm going to do. I may have thought about some of the different things that I want to do, but I haven't pre-planned any of it. So it's going to be kind of like a seat of the pants. So this is one of the other things you're going to see is all of these are going to be called part something, because I want to keep them to about half an hour in length. So this is part one. It might be part one of one. So we'll see. So right away you see this doesn't look like coding at all. This is a nice, lovely sort of window thing, and indeed it is. And if we go up here, you can start, or under debug, start debugging. You'll notice it has a hotkey of F5. I'll generally be using that. And if we run it, what we'll get after it has to build it first. So that's kind of turning the code into stuff that the computer can work with. And then it goes into debugging mode. So debugging mode lets you test stuff, and it lets you go into the code when there's a problem, and I'll show you what that looks like later. And it will usually take it a moment. Over here, it's connecting information and other things. So the first time you run this, it tends to be a little slow, and it will usually pick up. This is like how much memory is it using of your computer's memory, its CPU usage, just different stuff that happens. And after a moment, once it's gotten everything going, it'll pop up the window, which will look a lot like this right here. And there it is. Okay, so here we have our window. We can move it around, la-di-da-di-da. It's a lovely little form. We can resize it. This is one of the advantages of making a C# Windows Form application is it's very quick and easy to get this up. If you wanted to get this up in C++, you can, but it's going to take a lot more effort. So this doesn't do a whole lot right now. So we're going to go ahead and go to View Code. And this is where programming stuff actually happens. There's a lot of details about C#, and this is not going to go into all of the details, but there is some baseline stuff that I think is really important to understand. So using right here, these statements get us access to stuff that people have already made. They're called libraries, is a common sort of term for them. But this is just like we're using this stuff, and we can get to it like by typing out the full thing if we want to. We can go system, for example, .io lets us get into input-output stuff, and we can make a binary writer if we wanted to. We can do it this way. And it's red because it doesn't fully like this line. This is one of the things that's really nice about C#, is there's a feature in Visual Studio called Intellisense that sort of has an idea of what you're trying to program in terms of not what functionality you're doing, but whether or not the lines of code you've written are correct. This is not a correct line of code. If I were to try to build this under build right here, build solution, it's going to tell me the build failed, and I'm going to get an error list right here. And it's going to say semicolon was expected. So that's one thing that's really, really helpful, is it will tell you, hey, this line's not done, something's missing. In this case, it says a semicolon's missing. That's not all that's missing. If I try to build this now, it's going to be like, hey, binary writer is a type, and that's not valid given the current context, and only certain things can be used as statements. In other words, in C#, a line of code has to actually do something. That's not the case in C++, and that has caused me headaches over the years. But you can directly go to a thing. Okay, so the next thing we have is namespace. Namespace right here, it's just a way of saying this set of code right in here, it belongs together, right? It's kind of like the pages of a book. And then we have a public partial class. So there's a lot going on here. I'm not going to get into the details. Some of this stuff will come up. This is technically a form of inheritance. So it says this class has all of the stuff that this class has, and I'll go into classes later. And then it adds to it. Partial just means that we can split this class up among multiple files. So if we look over here in form1.designer, you'll see partial class form1 over here as well. That's because this file, we usually don't need to touch it unless something goes really wrong. And I've had to do that sometimes, but it's not very common. This is code that is automatically generated by Visual Studio. And partial just lets them put some of the code in this and allows us to put the rest of our code over here. So we're not like competing with files and getting our stuff overwritten. It's just a lot cleaner. So one of the big things in programming is just storing information. So we have different data types. They come in a couple of different flavors. So there's integers. So that comes in int, short, long, uint, ushort, ulong. These are all decimal types. There's also byte and sbyte. It doesn't like a lot of these because this is not like a valid line of code. So we use these to make variables. And for anybody who's familiar with algebra, a variable is a very useful concept there, and it's fairly similar here. This holds a piece of data. It represents a number. So just to give a quick example, if I were to make an integer, I could say integer I equals 10. Now the value of 10 is in integer I. And so the little green squiggle that you might be able to see under the I is just telling me, hey, this is fine, but it's a little weird. So it's telling me, hey, you made this variable, but you never used it anywhere. That's fine, because we're just showing things off, but just so you know what's going on. So I can also make like a short q equals 15. Now, I can't name two variables the same thing, because that's technically it's a redefinition error. The problem that you run into if you name two variables the same thing is it doesn't know which one you're talking about. You've overlapped names. Think about how confusing it is to do an algebra problem that's like two different x's. Like, yeah, that can happen with quadratic equations where x has two different values for certain things, and computers don't like that. So variables have to have unique names within their scope. Scope is a really important concept, and right here you see these curly braces that I've highlighted kind of either end of. Curly braces define scopes. So things live within scopes. So if I were to make, let's just get, well, this is a comment. A comment stuff that's not actually code. It's just kind of there. It's for you, the developer, but the computer can just ignore it. So if I were to do another, let's say, void tacos. So this is a function. I'll get to functions later. I can make another int I equals something here. And this is fine. These two int i's are fine because they're in different scopes. They don't see each other. But if I were to come over here and I were to make an int I equals 0, for example, all of a sudden we run into a problem. And if I build this, it's probably okay. So that succeeds. But the reason why is these i's are in a more local scope. They'll override this one. So if I ask for I over here and I'm like, hey, I want to add 3 to I, and I want to say I equals I plus 3, that's going to affect this I, not that I. So it's a little confusing, but it's really important to understand which I you're talking about. If I wanted that I could do that, but it's messy and it's just, yeah, it's a good idea to be careful about your variable names. Usually I'm going to use longer descriptive names. In short things like this, it's not as important. So I'm going to go a little bit over. Integer data types have to be whole numbers. And they come in two categories. So we have int, short, long, and sbyte. These are all signed. So that means they can have negative values. But your computer can only have so much space, only so much memory. So what you're going to run into is each one of these can hold a different amount. So for example, an sbyte is 1 byte. It's 1 byte of memory. And it can hold from negative 127 to positive 128, I believe, is its value range. Actually, if I go sbyte max value is 127 and min value is negative 128. Okay, so I was a little wrong, but all of these types, by the way, have these built in. These are constants that you can access that give you information. A short goes 32,767 on the top end and negative 32,768 on the bottom end. So these can be kind of thought of as how big they are. So an sbyte is 1 byte, and a byte is 8 bits. Each bit is a 1 or a 0. A short is 2, an int is 4, and a long is 8, I believe. Yep. You can see how big of a value these can hold, right? Longs hold really big values. Then there are byte, ushort, uint, and ulong. These are unsigned. So if you look at ulong, for example, its max value is enormous, but its minimum value is 0. So it doesn't have any negatives. These are really useful, though, because if you don't want to be able to hold negative values, then you have sort of a restriction, but they also have a larger top end, which if you're only working with positive values, sometimes that's fine. You can use something like a uint, for example, and hold up to, was that like 4 billion, as opposed to just an int, which can hold like 2 something billion. So it's just important to know there are certain times when you want to use one, certain times when you want to use another. Bytes are more commonly used than signed bytes. That's why it's byte and sbyte as opposed to byte and ubyte. So those are the integer data types, and like I said, they can only hold whole numbers. Then there are 3 other categories of variable types that are value types, as it were, or kind of built-in types. So there are the Actually, there's more than that. Okay. There's bool, which is true or false. It can only hold true or false. That's it. That's really useful, but it's kind of like its own small thing. Then there are the decimal types. The types have decimal points, and they come in two categories. There's float. Single might not be actually a name for it, but this is float and double. So these are floating point. And the way they work is they have sort of some amount of a number, and then it's a very complicated format. IEEE floating point specification. The important thing to note is a float is 4 bytes, and a double is 8 bytes. It's double precision, so sometimes a float gets referred to as a single precision. That's relevant in certain spots, particularly in input. So I'll talk about that when I talk about input stuff. Now, these are not perfectly precise. They will lose data. Like, for example, if I make a float f equals 0.1, I have to tell it that 0.1 is a float, otherwise it's a... This, by default, is a double. Like, if I hover over it, it says it's a struct system.double. C# does a slightly complicated thing, so... with its types, but float, I need to specify that's a float. It's less precise than a double in terms of like how far out it's accurate to and stuff. But 0.1 is not actually storable. So if I'm gonna get rid of tacos here. So if I come over to here and I go over to my toolbox and it will populate it, I can find a text box. Okay, so let's just put a text box here and let's name it. So this is something you're gonna see a lot. You can drag, these are controls, and you can drag them onto your form, and you can position them, you can resize them, and you can adjust a bunch of properties that they have. So I have a convention of starting each name with 2 underscores for controls, and it's just a naming convention that I have. So that way I know what they're called. So I'm going to name this guy textbox, and then let's go in here, and let's go textbox.text, so that's its text property, and this is going to get very complicated very quickly, but I can turn this into a string which assigns that. I'll talk about strings in a moment. They're for letters and stuff, but I just want to show this point here. So that's 0.1. It's showing 0.1. Let's see. That's interesting, because these can't actually store 0.1 properly. Let's see if I do... there's things with that I find it actually really interesting that it's displaying that properly. It seems to be rounding. How do I make it not round? Because it definitely cannot store 0.1 properly. Okay, so here's something else you're going to see from time to time. I'm going to use Microsoft Edge, because I don't use it normally, to look up stuff on msdn.com. So this is where I can look up toString number format strings. So if I search for this, I can get this information, and then I can look stuff up. So this is something that's going to come up. Okay, and I want... okay, n is what I think I want. Let's see. Maybe not. Like, I don't know, because I've definitely had problems with these storing 0.1 before. So maybe if I do like n5, what does that do? Does that do what I think it does? Huh, very, very peculiar. I'm surprised it's actually working. Maybe something like that. Nope. Okay, well, I'm just confused. But they do have some values that they can't store properly. I have encountered that. For some reason, this is not having problems, and I'm not sure why. But they'll definitely have. Okay, so I have to run an experiment for my own sanity. So let's start this guy at 0, and then let's do for int I equals 0, I is less than 10, plus I, f plus equals 0.1 f. And I'll talk about some of that stuff. Interesting. So that added up to 1 properly. Like I said, I've had this cause problems. So what I'm actually going to do is I'm going to put in a breakpoint. And yeah, see, there it is. The actual value of this is 1.0012. That's because it cannot store the 0.1 properly, and it was just truncating it, not writing out the full string. So this is the actual value in memory. So this is called a breakpoint. When you hit a breakpoint, it stops code and goes in and looks at stuff. So yeah, not crazy. Floats cannot precisely hold 0.01. It just, when you do this, it rounds it, which is inconvenient for display purposes, but convenient here. Okay. There is another type of decimal value, and that's literally decimal. Decimals are a lot bigger. They're like 16. Can I do size of decimal? Is this? Yes, I know. Okay. Text box dot text equal dot toString. This should be able to tell me, yeah, it's 16 bytes, which is enormous compared to other things. But it stores it stores decimal information differently, so it doesn't have that lossiness. It doesn't have that slight inaccuracy that you can develop with floats. But it's bigger, it's slower, that sort of thing. I like them a lot, though, for like utility applications and stuff, because you're not as concerned about speed. You're often more concerned about, is this accurate? Like for video game development, you don't want decimals probably most of the time. You want floats or doubles, usually floats. But decimals you definitely like for just this sort of thing, for utility application. And you'll see them come up a lot just because they are not lossy in that way, but you pay for that in how much of a memory footprint they have. And then there is char, which is short for character. So some people pronounce it car. I usually say char. I usually don't say it at all because I usually think it in my head. This is represents a single character. So for example, a lowercase a or capital A. Does this have W char? No, okay. These are automatically probably 16. So yeah, so these represent, UTF-16 code character. So I believe that these are by default a wide character which holds a full Unicode. In C++, you have to be very conscious about what type of character you're using because the normal char or char or whatever is the same size as it's 1 byte, and that holds ASCII, but it doesn't hold Unicode. So you don't have to worry about that here. There's also string, which you can't name it string. That's fine. Usually stir is what I use. This holds text. Yeah, that's what it does. It holds text. You can turn stuff into strings. You can add characters to strings. So it's useful actually to talk about a couple of these operators that you'll be seeing most commonly. So I'm just going to do this with int because these all generally work with int. So I equals 1. So there is assignment. That's the equal sign. It assigns the value on the right to the left. This is the R value. This is the L value for right and left. And the R value gets assigned into the L value. Now, there's also things like addition, subtraction, multiplication, division, fancy little thing called modulo, which gets the remainder of the division problem. Only works with integer types, but it gets the remainder of the division rather than the is it quotient? And that can actually be really useful, surprisingly. Then there are sort of the combined. So any of these can be written as like plus equals 1. This adds 1 to I and reassigns it back into I. So this is just a shortcut. You'll find a lot of these. You can make it times, divide, modulo if you want to. It's not the same thing as comparator. So this is something that's really important. So if I wanted to check what the value of I was, this is a Boolean result. So this is true or false. So I can check I against 1. So this is it equal to, less than, equal to, greater than, equal to, greater than, less than, not equal to. The exclamation part is not. So, excuse me. So if I have like, I can do b equals not b, which if it was true, it's now false. If it's false, it's now true. Then there is, this is and, this is or. I believe that's, is that Zor? I don't know. I know that's bitwise Zor. That a thing? I'm not sure if that's a thing. But Zor XOR is another way of saying it, is exclusive OR, which is really useful for certain stuff. It means one of these is true, but not both. I'm not sure off the exact top of my head. It doesn't come up a whole lot in logic statements. You usually will use like and or. It can come up in bitwise stuff, which I'm not going to talk about, just because that's kind of getting beyond things. So then we have other sorts of things we can do. We can do if. So for example, this takes a Boolean and evaluates it. If the Boolean is true, it does stuff inside the if. Otherwise, it does not, unless you have an else statement, in which case, if I is equal to 1, then we do the stuff inside the if. Otherwise, we do the stuff in the else. We will not do both, right? Because I cannot both be 1 and not equal to 1 at the same time. It's illogical. And then there's things like for, which you saw me use earlier. This says while it has 3 steps. The first one is initialization. So I usually would use int I here. If I'm using an integer elsewhere, I'm going to give it a better name. So for example, int I equals 0, I is less than 5, increment I. So something else that's really useful to know is plus plus. Yeah, I just expanded that to int. Let me go down here. Plus plus I is the same thing as I equals I plus 1 or I plus equals 1. And then there's also a minus minus, which is same thing as I equals I minus 1 or I minus equals 1. So this is the increment operator and the decrement operator. You can put it before or after the variable. It works on either side. There's some technical differences to them, but they don't matter a whole lot. I mean, they matter a whole lot if you're doing complicated statements, but if you're just doing by itself, it doesn't matter a whole lot the order that you do it in. There's while condition is true. Is a keyword. I'm not going to worry about it. So for example, while 1 is equal to 1, this is an infinite loop technically, so it won't ever end. But this will keep going as long as 1 is equal to 1. There's a variant on it called the do while. So the difference is if you have the while first, it will go in there, it'll check before it goes into the loop. This, you'll do the thing in the loop and then check. So it's useful. You don't see do whiles as much as whiles, and probably you don't see either of those as much as fors. Those are some of the important things. You also see switch. So if I make like an int I here, I can switch on it, and that will equal 0, sure. And this will basically, you can go like case 0, and this will automatically do case 0. So there's a lot of stuff going on here. The break says, okay, you're done with this case, jump out. It can also be used to exit loops early if you want to. So if I have something like while 1 equals 1 break, it will go in and be like, oh, well, that's true. Oh, wait, I'm told to get out of this loop. I guess I'll leave it now. There are other more complicated data types like classes and structs. These are objects. Now, everything is at its base an object. So this can be assigned anything. And it'll be like, yeah, that's totally information you can put in here. You can then say, for example, cast that into a type, and this will succeed if that is the right data. If this is like that, like this will compile, but when I run it, you'll see it should, yep, it throws an exception. It says, wait, you can't actually do this. And it breaks in the code and says, hey, this is wrong. You can't cast a into an integer. That doesn't work. That doesn't make any sense. So, it does have a value, which is kind of funny, but there's probably some way of like successfully doing it. But there's things like this form, for example. I can just make another one if I want to. Form1 form equals new form1. So this is something that's going to come up a lot. I'm not going to go into great detail here because I see that I've kind of hit the time that I want to hit. So this is going to be part 1. I will come back with a part 2 because I can tell that I have more that I want to talk about. And part 2 is going to probably talk about some classes and structs and things like that, functions, stuff that's really useful. So I hope you'll join me with that. And sort of the intention of doing this sort of overview is not 100% so much to teach people language, just that way I can make sure, hey, if you need an overview of the stuff that I'm doing in these Let's Program videos, you can come to the overview and take a listen. And this is also a series that I'm happy to expand as time goes on, as the need arises. So if none of the parts of the series cover something that you feel like is really important with programming or whatever, then I'm absolutely happy to make more parts to this. So this is part 1. There'll be a part 2. If I end the initial run of making these at part 2, I can always come back and make a part 3 if it's felt that it's necessary. So thank you for joining me. I hope that this is, at least in some way, shed a little bit of light on programming, so that way when I make actual programs, it doesn't entirely lose people. Okay, take care, everyone. Bye-bye.